Now that we've looked at exponentials, we're going to start looking at logarithms. And remember, exponential functions and logarithmic functions are inverse, so they cancel each other out. So to start with, we're going to look at logarithm with base b. Right? So we want b and x to be positive numbers, and b cannot be 1. And the logarithm of x with base b is denoted as log base b of x, and is defined as the exponent y that makes the equation b to the y power equals x true. Right? So this is just kind of a fancy way of saying it, but basically we go around the world. So if I have log base b of x equals y, to write this in exponential form, I'm going to start with the base, always start with your base, go around the world, go on the other side of the equal sign, and then come back. So then I would have base b to the y power equals x. And then likewise, to get back into from exponential into logarithmic form, I'm going to go around the world again. So again, start with my base, go around the world, and come back. So I have log of base b of x equals y. So we're just going around the world. So for the first example, I want to write log base 2 of 8 equals 3 in exponential. So I'm going to start with my base. So I have 2, go around the world to the third power, and then back, equals 8. So 2 to the third equals 8. Alright, now I have log, I don't know how to rewrite that. Log base 3 of 1/9 equals 2. So I'm going to start with my base. So I have 3, go around the world to the second power, and back equals 1/9. And I think that's supposed to be a negative 2. I just can't see it. So then 3 to the negative 2 equals 1/9. Now I'm in exponential and I want to go back to logarithm. So I have my base. So it's log base 3, go around the world, of 81 equals, we got to come back, 4. So log base 3 of 81 equals 4. Alright, and then we've got 81 to the 1/2 equals 9. So there's my base. So log base 81 around the world of 9 and back equals 1/2. So log base 81 of 9 equals 1/2. And we can use this to evaluate. I don't know what happened to my answers over here, so we're just going to ignore those. So I have log base 10 of 1,000. And I want to know what log base 10 of 1,000 equals. So I'm going to set it equal to x. And to do this, I'm just going to rewrite it in exponential. So I start with my base. So I have 10, go around the world to the x power, and then back equals 1,000. Alright, well I can solve this using common bases. So 10 to the x equals 10 cubed. So then that means x has to equal 3. Alright, and then same thing here, but now I'm looking for this in here. So I'm just going to rewrite an exponential. So my base is 27 around the world to the 2/3 equals n. Right, remember, rational exponents, power over root. So this is to the second power and a cube root. So the cube root of 27 to the second power, where the cube root of 27 is 3, and 3 to the second power is 9. So 9 equals n. Okay, then we have the property of equality for logarithmic functions. So if b is positive other than 1, then and log base b of x equals log base b of y, so I have the same base, that means that x has to equal y. So the example they give is log base 5 of x equals log base 5 of 8. So everything's the same. That means that x has to equal 8. Alright, so in this example, I have log base 4, log base 4. So just like with our exponentials, when our bases were the same, I don't need them anymore. So I can say x squared equals x plus 20. And we have a quadratic, so one way of solving a quadratic is a factor. And we have to set it equal to 0. So I'm going to move the x and the 20 over. So we get x squared minus x minus 20 equals 0. This is a plain Jane trinomial because my a is 1. So I want to go straight to my parentheses and find numbers that multiply to negative 20 but add to negative 1. So that's going to be negative 5 and positive 4. And then my last step to solve is to set each of these equal to 0. So x equals 5, x equals negative 4. Alright, the property of inequality for logarithmic functions. Alright, so if everything's positive, log base b of x is greater than y, then we're going to keep that same sign when we write our inequality. Alright, and then if it's less than, x is going to go in the middle, and we're going to use less thans on both sides. Alright, now keep in mind this is a little different because I'm putting my b to the y on the right side. So for this example, we've got log base 3 of x less than 2. Alright, so this is my less than sign, which means that I'm going to end up with, like if I have log base b of x less than y, it's going to be 0 less than x less than b to the y. So that x is going to go in the middle. So I'm going to go ahead and put my x in the middle. Alright, and then b to the y, that's going around the world, so that's my base to the exponent, so 3 squared and 0. 0 comes down, 3 squared is 9, so x has to be between 0 and 9. Okay, so a less than sign means you have to have two different numbers, so x is going to be in the middle. Then we have this property of inequality for logarithmic functions, and this kind of goes back to where if I know both of my bases are the same, like if I have log base 2 of x equals log base 2 of 7, I can cancel out my bases and my logs, and I know x equals 7. The same thing applies here. Okay, so if I have, like their example, log base 6 of x greater than log base 6 of 35, my logs and bases cancel, so x must be greater than 35. So for example, we've got log base 7, log base 7, so they can cancel out, and I'm left with 4x plus 5 is less than 5x plus 1. Solve for x, I can subtract the 5x over, so I get x plus 5, negative x plus 5 is less than 1. Subtract the 5, negative x is less than negative 4, divide by negative 1. That should be setting off an alarm. I'm dividing by a negative, so I've got to switch my sign. So then we get x is greater than 4. Okay, so the biggest thing we have to remember is that just like exponentials, if my log and base are the same, we don't need the log and the base anymore. We can just set our, whatever our taking the log of, equal to each other. Right, and that's the same for inequalities and for equations. Right, and then just go around the world whenever we are writing exponential to logarithm or logarithm to exponential.